infrastructure. What do we mean by integrated into a portal infrastructure? It should be widely available and available over the web. It needs to be secure, reliable, and the platform needs to expand. That is, we should be constrained for either the computing power or memory or the data storage itself. The complete tool set that is available in Microsoft BI includes the relational engine. The relational engine, which is the heart of it, in SQL Server 2012-2014, it started from 2005 onwards. There's a vast difference between SQL Server 2000 and 2005. All that I speak of is for 2005 and above. Of course, I'm referring more often to 2012 and 2014, the latest editions. So we have this relational database engine, which is the heart of the Microsoft Business Intelligence platform, because it holds all data in the form of tables and columns. We'll be able to build indexes and statistics out of it. Now, we will need to move the data, transform it from one type to another, which is what we do in SQL Server Integration Services. Once we transform the data, aggregated the data, bifurcated the data using facilities available in SSIS, we could build cubes on it using analysis services. Then, can I ask our audiences to mute, please? There's a lot of noise that I hear in the background. Thank you. So once we've aggregated the data using SQL Server Integration Services, we can build cubes using analysis services. The traditional cubes were multidimensional cubes in which the data was stored, separated, in which a copy of the data was made and stored in analysis services. Once it was stored, you could slice and dice, you could drill up and drill down as we pleased. And this allowed us to give better. Yes, please. And this allowed us to analyze the data better. We could also have reporting services, SQL Server reporting services or SSRS, from which we created drill down reports, normal reports, and certain dashboards. To support all of this, we had some notification services to say you're running out of space, or things like, you reached a threshold in business, so you need to celebrate, or it's like an alert that you need to go and take action against. All this would have been futile without a complete search, and SQL Server Integration Services, SQL Server also supports a full text search. When we had all these facilities of SSIS, SSAs, and SSRs, we needed to ensure that we have high availability and capable of recovering from a disaster. So, from time immemorial, that is from SQL Server 2005 days onwards, we had a number of alternatives in the form of log shipping, and then replication services, clustering, and so on. The latest being always on. Always on is a disaster recovery, high availability platform in which we assure 99.999% of uptimes. Apart from that, the secondaries are readable. They are active. So because they are active, it will enable us to store more. It will enable us to take backups, it will enable us to take reports from the secondary servers, reducing the load on the primary server. This is the complete tool set that we have as a part of SQL Server Enterprise Queue, which will be the case in most production systems. Now, what exactly is the BI lifecycle? We take data from different sources such as an OLTP database, ERP databases, departmental databases. It could be stored on Microsoft SQL Server or IBM databases, Oracle, Teradata, or SAP. It doesn't really matter. We prepare the data. We do an ETL or an ELT, extract, transform, and load, or extract, load, and transfer in order to filter, cleanse, and do it on a scheduled basis so that we are always up to date with the OLTP system. Then we build a data warehouse, which is again another database consisting of aggregate information along with the lower level information. Sometimes we also create data marts, and this is optional. Why do we create data marts? The difference between having disparate sources of data at the OLTP level and again having data marts is the data sources are all application oriented, whereas the data marts are subject oriented. For example, If you have HR database, finance database, ERP database, and a transactional database, the data mart would be vendor data mart or product data mart, where we are analyzing with reference to a subject. Now, we also build in-memory analytics on top of our data warehouses in the form of OLAP cubes. We build a data access layer. It could be reports, it could be drill down reports, visualizations, graphs, supporting ad hoc queries, and finally build dashboards. In this entire life cycle, the one step which takes a lot of importance is the data preparation stage. The data preparation stage takes the data from the data sources into the data storage or the data warehouse or the data mart. So, what is our tool? Drilling down on that portion of it, we have SQL Server integration services. We have the ability to read data from different data sources and then write into the destination database. How do we do it? Some of the common tasks that we have are bulk insert task. That is like a bulk copy, BCP. So you can, with reduce login, you can insert a bulk of the data from the source system to the destination system. You can profile data. If you have created other SSIS packages, you can call them here. You can execute them. In a script task, you can write what business logic that you would want and include a send mail task. Some of the other tasks that we normally use are conditional split. Separate the males and females in the list. Separate all people with income of less than 20 lakhs and more than 20 lakhs. Convert the data from one format to another. Convert to the SI standards. For example, convert age into number of days. You get an additional derived column. We always have a list of master data, so do a lookup with master data. If you are, for example, entering addresses, pick out all the zip codes and make sure that the zip codes are there in our master data, otherwise the record is bad. Or maybe we need to update our master records. We can merge data coming from different sources. We can multicast the data, that is, we don't have to write to one single destination. We can make copies of it and give it to different locations. We can do a union all, sort, row count, and slowly changing dimensions are also available. Now, apart from that, we have certain other tasks which help the admin folks do it. Like, for example, the CDC control task is one of my favorites. Let me tell you what exactly CDC is and how can we go about it. Okay. I'm switching my screen. And now we are looking at my SQL Server Management Studio. Right. So, I have a very simple sample CDC database here. And let me expand this database. What do you see in this database? You see just one table called student. Switching over to my sample CDC database with just one table in it called student. And then it has got 3 entries, Deepti, which is me. My gender is female. I'm a student here. There's my friend Divya, who's also a female, and Piyush, who's a male. Now, let me add what is exactly CDC and why is it needed? In the data warehouse in World, we have got 2 main types of tables. Dimension tables and fact tables. The dimension tables are expected to change very slowly. Some of the students may leave this database because they have graduated, or let's say they have a fatal accident and they are no longer there, or they've decided to take a transfer to a different university. There are definitely new students who will take applications every year, and there are people who could change certain characteristics. For example, they could change their name because they got married, they could change their address and so on and so forth, which would need some kind of maintenance. The problem is, if we have 1 million students, how do we identify what has changed and push those changes alone into the data warehouse? Which is why we have 3 different types of slowly changing dimensions. Now, To read from the source and identify what has changed is the biggest problem. I'll show you how it has been implemented. Okay. Now, if you look at the system tables in a database which has been CDC enabled, you can see that there are different kinds of data tables, system tables which are formed on its own. If I do a select star from student CT, which means change track, okay, I can see that the operation type is 2, and it is telling me that these are student ID, student name and student gender, these are the values. Now, if I go back to my student table, okay, I am going to edit the rows in the student table, and if I write my complete name saying my name is not just Deepthi but it is Deepthi Anantharam, there was a mistake in the application. Let's see what happens. Now, first of all, querying back the student database to make sure that the name has been updated. Now I'm querying the student change tracker table where I see that there are 2 rows. That means whenever there is a modification, there are 2 rows inserted, one with the older value and the other with the newer value. You can also see that the operation type is 3 and 4, right? That means 2 is for all the new inserts. Let me insert a new student to get the operation ID of 2. So I'm going to say student 4 is Manoj and he is a male. I will say student 5 is Rashmi and she is a female. Okay. Now that I have done that, if I take a look at my change tracker table, I see that only 2 new rows have been added, confirming that whenever a new entry is made, it uses 2 and it uses 4 in order to say that the values are updated, and 3 is all the old records of 4. What is 1 used for? 1 obviously is used for delete. If I edit the rows in my table and then drop Rashmi from this, I can see that I have got operation. You should see in this column, column 4, where it says $operation, that the type is Rashmi, right? So now we know that we have a change tracking table where we can just take a look at 1, 2, 3, 4 and then figure out what are the new entrants where operation ID is 1. What are the new entrants where operation ID is 2? They are all the new people in the database. Where operation ID is 4, they are all the deleted people, and where operation is 1, where operation is 4, they are all the updated records. Once we have figured this out, it is far more easy for us to extract this information and take it onto the data warehouse. How did we go about doing all of this really? Let me create a sample database now to see how difficult or easy is it to enable this for us, to enable CDC or changing of data capture. I created simple database called TechGig. As you would expect, there are no tables, there are no system tables, or there are no file tables in this database. Now, one thing before you enable CDC is you should always have your SQL Server agent running when you try and create a database to say what records should be available in it to make it CDC enabled. Okay. I am going to get a set of records, just bear with me. I'm going to open a new query window and then point to the latest database that I'll use called TechGig. Before that, I am going to check if this database, by using the master table, if it is CDC enabled. As I would expect, I would see that there is only one table, sample CDC, one database, which is actually CDC enabled. So how do I enable this TechGig database for enabling the change data capture? All I have to do is execute a stored procedure called CDC enable DB. I'm going to go ahead and execute this. I should have used a use database command. Now I'm going to just change it manually and execute it again. Executing the stored procedure will take like a minute, and then when I refresh this database TechGig again, you can see that there are a number of system tables which have been created for capturing columns, for capturing the changes in tables, to capture any DDL history. It does not mean that once you have enabled capturing of CDC on a particular table, you can't change it. If you have changed indexes, what is LSN? LSN is log sequence number. Just as any table will need to have a primary key for good database practices, we have the log sequence number as well in a log file which is stored within LDF. Alright. And now we've enabled the entire table, right? Now, which database needs to be enabled? There are no databases on this. We'll have to create a database and run one simple stored procedure again to which is SPCDC enable table. First we did SPCDC enable database. Now we need to do enable table. You'll have to say under with schema, what is the name of the table? In the previous example it was student. You can change the name of the table to whatever it is. Mention a role name which would go with it, execute the stored procedure, and then you will be able to capture changes. Why is this so important? What is the role that it has played in the industry? Switching back to my slide, I'm sure you must be familiar with Punjab National Bank. It has existence in 6 different countries and has serviced over 82 million esteemed customers. They had an Oracle. They still have an Oracle OLTP database for their transactions, which is the payment systems, and then they built their data warehousing strategy in using DB2. But then they needed to understand and identify the changes which has happened in the Oracle OLTP database and push it on to their data warehouse which was on DB2. And how did they do this? They did this using SQL Server Integration Services CDC, which is the most cost-effective solution when compared to things like Golden Gate, where you need to install it on both places. You saw how easy it was for me to enable CDC on my SQL Server. Similarly, there are the steps in order to do it on the Oracle server. The question most people here would have is, will Oracle also support CDC? The answer is absolutely yes. Any database which operates on the logging principle, because there are many advantages of the CDC. CDC reads the log file. It does not read the master data file. Since it does not read the data file but reads the log file, it does not log any other transactions which are happening. It is faster and it's a cleaner solution. Using the CDC, they were able to take the 6 hours window of identifying the changes in their online payment system and take it to the data warehouse. They reduced the time by 6 hours. And when this happened, their personnel were able to go home on time. They were able to make better decisions with reduced delay. Now this all that it cost them was the implementation cost and the cost of SQL Server licenses, because the license itself includes CDC. It is not separately charged. Now you know the power of SQL Server integration services. There are certain other common data quality issues that we have. For example, when data comes from disparate data sources, how do we codify them? In the previous student example, we were using M for male and F for female. People also use 0 and 1. Or people could go ahead and completely type out male or female. How do we standardize this? Let me give you another example, because I know this is a very common example. Let's say I have a person, my neighbor is called Joe. Because he's a friend of mine, in my telephone book, I would simply call him Joe. Since his interests are in gardening and my mother has a green thumb and does a lot of gardening, she has listed him as Gardener Joe. Similarly, depending on different attributes, how we meet people, we all encodify and decodify in our minds and associate all the names that we know. It's similar when you make shopping lists, city lists, book lists at home, and so on and so forth. We need to have some standards within the family in order to identify and for all of us to use and leverage the facilities. Similarly, we need to have standardization within an organization for all codes that they use. Is the data complete? Is all data necessarily present? I mean, if you analyze the list of risky countries, you would find that a lot of dubious accounts belong to Afghanistan. It could be true that Afghanistan also has a lot of spurious accounts, I mean bank accounts, but it is also possible they have just left it at the default one because it is the first country that comes in the drop down. Similarly, the most common zip code is 99999 because people wouldn't want to say their zip code or wouldn't know it. Now, we have another problem. Is the data real and verifiable? Let's say I have a supplier, but the supplier is not really active and he has gone out of business 2 years ago. Now, I have no way of identifying whether the supplier is active or not. Is the data valid? In a numbers range, if you see that, for example, if I see something like 309, I can pick it up immediately and say, age cannot be as big as that. The oldest man alive is 124 and most people who transact would be less than 80 years of age. The thing is, the computer brain cannot pick up these problems easily. For it, it's a number. So we need to train it in order to identify these issues. And then, the space problem is an old known problem to say that data sometimes is not unique and why it appears several times. In order to resolve all these problems, we have integration services which will help move data from one position to another, from the source system to the destination system. We have master data services which will help us in building cleaner data. Like everybody will be able to understand Joe is our gardener and neighbor, and improve the quality of data so that we have some knowledge base built within us and rules for utilizing that data. All this, the role of complete, current, consistent and clean data is achieved using SQL Server integration services. Let's move on now. What exactly are cubes? As kids, all of us have played with Rubik cubes. In fact, in the 1980s, it was so popular. And then, otherwise, we would have definitely played a game of snake and ladder or Ludo using the dice. The data cubes are something similar. Just that geometrically, they can be a cuboid, like you see. It may not always have equal number of sides. In the cube that I am representing here, there are 3 products, 1, 2 and 3, 4 days, 1, 2, 3, 4 and 5 regions. So now a cube is something which has data and has got multi dimensions to it because the tables that we are referring to in the racial engine was all 2-dimensional. Now, data cube can be defined as a combination of dimensions and measures. So we've got dimensions, we've got measures. What are dimensions and what are measures? Dimensions consist of attributes and attributes consist of hierarchies. For example, if I say year is a dimension, year has got attributes like, it could have months, it can have months, or let's say a student is a dimension, or employee is a dimension. They have different attributes like date of birth, address, gender, what are my physical attributes, which location do I come from, what is my educational background, and so on and so forth. If we can arrange the attributes which are related in a way that we can traverse up and down the attribute list, it's called a hierarchy. For example, going back to the year as a dimension example, if we have year, quarter, month, week and day, then it becomes a hierarchy. Similarly, we have geographies where we have country, state, city, villages, districts, talukas for people who are familiar with the government, and so on and so forth. Now, the thing is, if we had only dimensions and attributes and we had measures, we didn't really need a cube to do it because we could somehow manage this with complexity inside a relational engine. What is the additional thing that we can do with a cube? We can define new calculations in a cube. Calculating everything at the data loading stage is not viable. There are a lot of calculations which can be done in the cube. We can define key performance indicators. A measure is something which is as of date. A KPI has a status and a goal associated with it. We can do different actions like go to a particular location when this happens. we can have partitions within the cube as we can have partitions within the table. We can have perspectives which are similar to views. That is, you can show only a portion of the cube with some measures which you would like to expose. And we can support different languages using translations within a cube. Let me show you, for those of you who are totally not familiar with cubes, when you install SQL Server Enterprise Edition and or the BI Edition and decide to install the complete cube version, you could go here and connect to analysis services. When you connect to analysis services, you will see this. The shape of the server is a square like a cube and not cylindrical like that of a database. I have only one cube here called a sales cube. I have all my metrics which I need, like cost price, selling price, count, and quantity sold. Let me drag and drop the quantity sold. The quantity sold is 52,666. Now there are three dimensions: product, stores, and time. If I say show it to me by item type, it does show it to me by item type. Now if I say show it to me by item type and quarter, it's giving me the breakdown. If I just change the alternative, if I say, okay, show it to me by quarter and then by item type, it does the same. If I want to apply a filter here, if I go and say apply a filter on time, I'll say, since we have taken two dimensions here, let me take the third dimension. Let me say give it to me by stores. And within stores, let me say give me the state name operator. There are a bunch of things: equals, not in, equals, contains, and so on. I will pick up equal because it's a small list here. And what is the filter expression that we need to filter it on? It's a tick box. So I'll say give to me only for state 1, and it has shown me all the results for quarter 1, for the item type, for the quantity sold for this particular state. Now, how did we all end up writing this? If I go into the design mode, I see the select non-empty measures or quantity sold on columns and so on and so forth on rows with certain flag setup. This language here is called multidimensional expression language, or MDX. MDX is a way to query the cubes. When we were dealing with cubes in the olden world, the cube data was, was very powerful, but kind of slightly difficult for people to write MDX. So what is the latest innovation that we have in that field? We did have MDX. We had two types of data format, MOLAP and ROLAP. Recently, in the business intelligence semantic model, we've added the tabular model. In the tabular model, you can build these cubes and they will be completely residing in memory. Cubes are built using SQL Server data tools or a Visual Studio shell, and the Visual Studio that is used for the construction of tabular cubes is not licensed. Now, the other beauty of it is you can build a complete tabular model using Excel itself. In this you have data crunching so that it holds a lot of things in memory. The thing is, you can also persist this and write it back onto the disk on the tabular model. Please bear in mind that you will have to install analysis services twice, once in the traditional MOLAP method and once more in the tabular method in order to support both. You can have both installations simultaneously on a server, but then you will need to have both of them in order to use the in-memory cubes which are possible to be built using the tabular model. So now you can access data from different line of business applications, files, OData feed, and cloud service. You can build either the traditional MOLAP method where it is very powerful, or you can decide to do completely everything in memory. People like Indigo have a classic case study where they do everything in memory, and you can access using reporting services, Excel, Power Pivot, SharePoint Insights, and other third-party tools. BISM is so easy to use and so fast that it can be used for personal BI if you want to analyze something on your own. If you need to share that with your team, you can put it onto the SharePoint site using Power Pivot. or you can put it onto tabular services, tabular analysis services, and share it with your entire organization as organizational BI. The newest and the powerful way to work with data is to use Excel. Now, there is another webinar by my colleague Sudhir Rawat who will talk to you about Power BI in a lot of detail. I definitely would suggest that all of you attend that session. We have the ability to discover data using Power Query. Analyze data as in build data models in Excel. That's right. You can build relationships, you can build hierarchies in Excel using Power Pivot. And finally, you can visualize the data using Power View. There are certain geographic data, if you would like to represent it in the form of a globe or in the form of a map, you could also use Power Map. Let me just show you how a dashboard in Excel, which can be built in minutes, look like. Here I have this dashboard with me, which says that there are about 6 or 7 distributors of data, and they serve beverages, breads, fruits, and vegetables. They are served in different colors, and it is sold in 3 different varieties. It could be sold as is. For example, let's say the drinks are sold as is. Certain things are sold cold, and beverages like coffee, tea are sold hot. So if I just click on beverages, so it's telling me that a lot of beverages were sold as is. Looks like it's all fresh fruit juice. Oh, sorry. Small quantity of beverages were sold as is. A lot of it was sold cold and a lot of it was sold hot. The brown beverages are likely to be coffee and tea. There was nothing green, orange or red beverages which was served. Again, looks like white milk and probably yellow juices. Now, the question I have is, then what was green in color? If I click green, I can see that the one which is green in color was all sold as is, and as expected, it's fruits and vegetables. Here I find that this small piece, the field trip store, sold only 40 of green items. So what did it sell? If I click on this, it's telling me that it sold a bit of all colored fruits and vegetables, of all kinds of beverages, and everything in some small quantity, a lot of it hot and as is. So who sold a large quantity of the fruits? Now, fruits were sold equally by almost all the stores, and the fruits were green, orange, red or yellow in color. There were no fruit which was white or brown in color. Look at the interactivity between this. I have not built this off a cube, though it's possible to build this off a cube now. I have built it off a simple relational database which resides in SQL Server 2012. If there are no, it depends on foreign keys. If the foreign keys were not available, you could build it on Excel too. Okay. In order to complete the look and feel of this, you could also set up the different themes as we would do in a dashboard for some look and color format. If I am a reddish person, I could change it from blue to red, and look at this, even the font of the heading changed. If I want, I could set up a background. It's going to make it look a little dull, and then this is it. It is. Or let me go back to making it more yellower themed, and there it is. So it is so simple to build this dashboard that it has taken less than 5 minutes in order to build this, and I could push this onto a SharePoint site and people can view it directly on the server using a browser. The beauty is when I take a download from the SharePoint site in the form of a PowerPoint report, even the PowerPoint report will have the same kind of interactivity that we have seen now. How can this story of BI be complete without moving to the cloud? Why do people move to the cloud? It reduces organizational costs. There is built-in scalability. All the data that is stored in the cloud has got 3 replicates on SQL on Azure. So there is a very high HADR and there is maximum proofing. Depending on what services of the cloud that we are using, the hotfixes, the patches are updated on the server automatically. What is the specific advantage of moving BI to the cloud? In a BI scenario, it's very difficult to estimate the size of the hardware. For example, today if I want to start with 500 GB of a warehouse, I wouldn't know where I would stand 1 year down the line. So do I order for 2 TB? No. I would be based on a lot of infrastructure requirements. Now, when I could move on to the cloud, I wouldn't have to worry too much because I get paid for what I use, and I can automatically increase the hardware on the fly. It reduces significant hardware costs, and it potentially shortens implementation time. Depending on how you are moving to the cloud, you could move your virtual machine completely to the cloud, and there are certain built-in templates which are available. So you could sign up for Azure today and say, I want a virtual machine with SQL Server 2012 installed in it with 32 GB RAM and 500 GB hard disk, and it's available to pick for you out of a template, and you could start using immediately. There are 3 common ways in which we can go to the cloud. Infrastructure as a service, also called as hardware as a service, in which case you have your VM, you can pick from a variety of templates available, or you could build completely from scratch, or you could move whatever you have on premise onto the server. You could use platform as a service. Platform as a service such as SQL Azure, where you don't have to worry about network or virtualization or operating systems. You only have to worry about your application and data like SQL Azure. Or you could simply sign up for something like HD Insight, which is our big data solution on the cloud, which is born in the cloud, and then use it off the shelf. Of course, when you start using it off the shelf, there's lesser amount of customization that you can do, but you can definitely build powerful solutions with what is available out of the box, and the implementation time is the least. In order to complete the BI story, we need to include a huge variety, velocity, and the variability of data that comes in. Initially, we only had the ERP of the CRM systems where we had payrolls, inventory, contacts, and such other information where the data was in megabytes or gigabytes. And then in the Web 2.0 world, we started, looking at advertising data, mobile data, e-commerce data, a lot of logs that got generated, market intelligence, digital intelligence, and the data moved up to terabytes. Today, we have click streams, wikis, sensors, RFIDs, audio, video. The variety and the velocity and the variance of data is very, very huge, and hence the data is in petabytes, which is what is big data. In order to manage big data, there are 3 things that we need to do in order to use big data. One is manage this big data, right? And then the other is to enrich the data, and finally gain insights out of it. To manage data, you can also use SQL Server. If the data quantity is very huge, like exceeding in TBs, we also have PDW or Parallel Data Warehouse version 2.0, which is an appliance. An appliance is like a refrigerator. You take it, you plug it, and it starts working. You also have Microsoft's HD Insight Server, which is software as a service available on Azure Cloud. If you need the on-premise version, we also have HDP, Hortonworks Data Platform. In order to enrich the data, we have to club the data that we have with the computations data, with the data available because of market intelligence from different consulting and organizational committees. Right? We also have Windows Azure Marketplace, which will suggest data sets to you. For example, if you are analyzing citizens' data, Don and Brad Smith could suggest that this data set is most useful for you. In order to get insights out of this data, you could build traditional analysis services tools, or even use Power BI, which Sudhir Rawat will speak of in a lot of depth, in order to gain rich insights out of it. So basically, this is what I had to talk to you about the Microsoft BI stack. It's a complete story with integration services helping us to move data, analysis services helping us to build cubes, and reporting services helping us to report. We have the self-service BI story where the end users using Excel could build dashboard within minutes, drag and drop their parameters and create relationships. And finally, we also have a lot of data mining capabilities out of Excel. Not all business intelligence needs are the same, otherwise it would have been a very boring place. In the Microsoft's BI offering, you have the flexibility to create the BI environment that best fits your needs. Whether you need the traditional SQL Server reporting services, Power Pivot, or full-blown Power View, Azure provides the building blocks for your solutions along with all the set of on-premise solutions that we have. Now, there are a lot of SQL Server 2014 features which have been released. The basics in the BI world remain the same. The biggest change has been in providing memory capabilities, in-memory capabilities for the relational engine too. Basically, this is what I want to talk to you about, and we are also running out of time, so I would like to take a few questions if you have any now. You could type questions in the question panel that you have. I'll be able to see the questions and I'll read it out aloud and send out and speak about my answers.
Thanks for the insightful presentation, Deepti.
I would ask you to speak about SharePoint here, because it's a big part of our BI story. It is the collaborating medium we have for all our reports.
Yes. So as you have already mentioned, let's quickly take up the questions now. I would request you to read out the questions and their answers so that all our users may listen to your insights. So are you able to see the questions coming into you?
Okay. Yes. So Abhijit Nikam, you've asked me why you need to have SQL Server agent running in order to enable CDC. See, when we enable CDC on a database, there are certain jobs which are automatically created. We were concentrating on the tables that are present and what kind of data that they capture. But if you go to SQL Server agent and take a look at the SQL Server agent, you can see that there are CDC underscore capture and CDC underscore cleanup jobs, which will run some certain stored procedures. Since these jobs are created, you will at the time of enabling CDC, it is advised that you have the agent always running. In fact, if the agent isn't running, it will error saying that you do not have the ability to do it. I hope that answers your question, Abhijit. Okay. Ankita has a question. How is BI helpful at the managerial level? Like I said, Ankita, the history of BI starts with, making decisions, in order to enable people to make decisions, strategic decisions. How do we plan for the next year, and so on and so forth. So if you look at all the decision support systems, the decision support system and the management information systems was why all the data sources from different OLTP systems was clubbed in the first place in order to build a data warehouse. Most users of data today are the business users, which is why we are stressing on self-service BI capabilities where the end users can build it themselves. Okay, I'm jumping a little. It's what's the difference between SQL Server 2008 R2 and 2012? Satyendra Kumar. See, in SQL Server 2012, first thing, there are a number of differences. If I have to point out two top ones that come to my mind, especially in a warehousing scenario, the first one would be the column store index. We have three types of indexes which are supported. Clustered index and non-clustered index. In SQL Server 2005 onwards, we also had the covering index. So what exactly happens in column store indexes is data is stored in a columnar format. In fact, if time permits, I would have run the demo for you, where when you start using column store indexes, especially applicable for huge tables, that is millions of records, it's going to make retrieval of the database, of the query, that much faster. So one is the column store index. We had a drawback in SQL Server 2012, Satyendra, where column store index was not updatable. Now column store index is updatable in 2014. The other important thing, though people say whether it's a DBA feature or a BI feature, we have the introduction of always on. Always on is the best HADR scenario we have in mind, where we have 99.999% update time. So when a database falls, there is a always on availability group. if one of the databases on which application fails, it simply switches on to the other server and it does this automatically. Always on is a huge topic by itself, but I hope you understand HADR scenario and how it has happened. Okay. Satyendra has another question: how to improve business analysis and reporting? Well, adopt latest technologies, but then like BQS, MDS, whatever we have in the Power BI options, the data quality is very, very important, and ETL becomes very important here again. We'll have to take at the situation. We'll have to look at the situation and then answer the questions. Abhishek Gupta, how can we export multiple XML files in SQL Server using SSIS? See, you have a for each container and then you can have adapters which will take XML data and input it in. It's not an issue. How does Microsoft Parallel Warehouse works? This is the question of Surendra Dattatray. Surendra, I'm assuming you're asking me about PDW. So, what PDW does is, let's say you need to cluster, right? Beyond the point, one single server cannot handle more than a particular level. So, what do? You start having appliances one stacked next to the other. Over a period of time, managing installation, networking, latency, the network blades and all, within all of that becomes complex. So, in order to avoid this complexity, you have the availability of taking quarter rack, half rack, 3/4 rack or full rack from HP and upwards of course, or 1/3 rack, 2/3 rack and full rack from Dell. So you have the hardware, software, installation and configuration all done. Like I said, it's like a refrigerator. You bring it, you install it, you plug it in and it will start working. All the other basics are taken care of. And we would recommend this if you are using data above 5 TB in size. Rajesh Kumar Patel, the question is, how will we track the CDC sequence if you want to restore the data? Why would you want to track the CDC sequence? Anyway, we have the log sequence number or the LSN. The log sequence number should tell you from where you need to restore it. Okay. Anand Soni, the question is, what are the visualization options for Power Pivot on the web? So, Anand, Power Pivot is a tool which is a plugin to Excel, which will help you create data models within Excel. So, you can create relationship between tables, hierarchies, you can create KPIs within it, and you can share that on SharePoint site so that it is accessible to everybody else. The Power Pivot is a modeling tool. Using that, you cannot definitely have direct visualization. By visualization, if you mean something like a report or a dashboard, you can have Excel reports made out of it, and you can use Power View and Power Map. Okay, Vivek Singh's question is, what are the differences between multidimensional and tabular cubes? A multidimensional cube is disk-based. So, in multidimensional cube, you can store data either completely in the cube, or you could have a hybrid model, or you can depend completely on the underlying ROLAP database. You can depend completely on the relational database. So if you depend completely on the relational database, it will fire the query and get the results. Only some metadata is available in the cube. So basically, it is written onto the disk. The tabular cube is written completely into memory. Only when you are closing down analysis services, you can say flush it out and save it onto this disk, and it will do it. Tabular cubes are expected to be much more performance oriented. It might not hold the same huge volume of data as a multidimensional cube though. And the methodologies in which we can access the data, as I showed it to you, to look at data inside a multidimensional cube, you will need MDX queries, which is a hard skill set to acquire or to find. Whereas in tabular cubes, you can use data analysis expressions or DAX, and these are very, very similar to what you have in Excel, like a sigma to say aggregate the data and so on and so forth. Sayantan Mandal, what is the difference between OBI and MSBI in respect of capabilities? You mean in Oracle BI? Oh my God. The difference is, see, we have a complete, first of all, I will look at the licensing differences. We have SQL Server Enterprise Edition, we have SQL Server PI Edition. in both these queues, you get all features that is needed for BI. You have reporting services, you have analysis services, you have the underlying data warehouse, and you can also send notifications and so on and so forth. Like I mentioned, even CDC is a part of the entire stack. Whereas in OBIs, first of all, you don't have something for movement of data across. And then the reporting capabilities, the kind of power map reports that we have, where you can represent the entire data on the cube, and you can also create a video of it where it will show you how much it moves with respect to times is not possible. That kind of capabilities is not possible. Cost again is a huge factor, and things like CDC are separately licensed as Golden Gate, which we don't do. So if you have SQL Server Enterprise Edition, you can do almost all the things that we have spoken of today, including having 99.99% availability. Whereas there is a separate solution again in OBI. OBI is for me only a reporting layer for which you need to build it metadata. Anup Kumar Karwar, can you explain your question to me a little more? What is the different schema used in SSAS? Well,
Deepti, sorry to interrupt.
Schema used, we don't actually use a different schema. What we would do is we would we create a data source connection. We pull whatever we want into our data source view. We create additional relationship between dimension tables and fact tables, and then we create attributes and metrics and hierarchies, and then we do it. So it's all a metadata that is used in SSAS. It depends on the underlying data warehouse that is in place or the data mart.
Nitina, sorry to...
I think that is the complete set of questions, and we are right on time as well.
Yes. Deepti, we are getting a lot of questions. So I would request you to now sum up the session for today. We are already running behind time. So if you would like to sum up the session, you can do it now.
All right. Like I mentioned again, the not all business intelligence needs are the same, but then MSBI offerings help you to create a flexible BI solution that best fits your organizational needs. It is available on the premise and on the cloud. Do explore all of it. If you have any questions, do reach out to us on our Twitter handles and on the MSDN forums, and we'll be glad to take any questions. Thank you so much all for attending this. There are a series of 5 webinars being organized by Microsoft, all Microsoft speakers. I would request that you also attend the complete series in order to get a better overview of SQL 2014 and in-depth BI features. Thank you so much.
And I'm really thankful to our guest speaker today for conducting this informative webinar. But due to time constraint, I have requested Deepti to take the unanswered questions offline, which I will share with her through email. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Deepti, for taking the time out and having us. I hope you have a great evening ahead.
Thank you.
Thank you. We'll be closing the session now. Bye-bye.